Chapter 1, An Introduction to Networking, Part 2. So we're going to dedicate the entire second part of our lecture this week to introducing and covering the OSI and TCP/IP network models. Now, this information is so foundational. It literally creates the foundation on which we'll build the rest of our knowledge over the next 16 weeks of the semester. I'd go so far as to say that you will apply what we're going to talk about today daily during your career as network professionals. Now, so before we get started on such a technical topic, we're going to tell a story. All right? And it's going to be a story of two CEOs. We know what CEOs are, don't we? Chief Executive Officers. They're people who are at the head of their companies. And we can tell right here they are. Here's the CEO of Acme Corporation. That's the company the Coyote kept buying all his equipment from to try to catch the Roadrunner. And we have the CEO of West Coast Traders. Wondering what West Coast Traders is? Once you take your Microsoft certification exams, you'll know exactly what West Coast Traders are. And obviously, these people are important, right? They've got little briefcases and neckties, so they're definitely at the top of their game, and they are the head of their companies. Well, this CEO, we should probably name him. I'm going to call this one Bob, for lack of anything better, and I'm going to call the CEO of West Coast Traders Susie. Well, Bob wants to communicate with Susie. And he certainly could just pick up the telephone and call her, but maybe there's some protocol in place that defines how these two companies talk to each other, right? There may be rules they have to follow. So Bob wants to send a message to Susie. He wants her to meet for golf. For these executives, golf isn't goofing off, it's networking, quote unquote. So to get the ball rolling, Bob sends this message to his secretary. Right? Well, again, there could be protocols in place for the way communication between these two companies happen. So the secretary may take this, and maybe Bob gave it to the secretary on a Post-it note, or the back of a cocktail napkin or something, and the secretary types it up on company letterhead, right? Applies formatting to it, makes it fit some protocol that the two companies have agreed to. Maybe this is a big secret, and Bob doesn't want anyone else knowing that he's meeting the CEO of West Coast Traders for golf. So maybe the secretary also encrypts this message. Could be, right? So it takes it puts an encryption, scrambles it all up. Well, the secretary is pretty high ranking also. I mean, he's pretty high up in this organization. So he's not going to jump in his car, drive over, and hand it to the CEO of West Coast Traders. He's going to turn around and hand it to a middle manager. The middle manager's job is to decide what kind of delivery is this message going to get to West Coast Traders. Is it going to be guaranteed delivery, or is it going to be unreliable delivery? Right? We know what guaranteed delivery is. It's when you go to the post office and you get that little delivery confirmation sticker that you put on the side of the envelope, and you fill out all your address information. And when it arrives at the receiving end, the recipient tears that off, and they toss it back in the mailbox, and the delivery confirmation comes back. Maybe we don't care, right? Maybe we're just going to throw it out there and hope that it arrives. It's kind of like going up to the beach and taking messages and putting them in bottles and throwing them into the ocean and hoping it lands on Portugal on the other side of the Atlantic Ocean. It might not. We'll never know. At any rate, it's the middle manager that makes this decision. What kind of delivery do we use? Now, sometimes the middle manager may not have a choice. There may be protocols in place for different kinds of communication. Maybe there's something that says that any communication from Bob the CEO has to go by reliable protocol. Maybe there's some protocol that says otherwise. At any rate, the decision is made here at the middle manager. Well, the middle manager is still a manager. He's not going to drive that over to West Coast traders. He's going to send it down to the corporate mailroom, right? Corporate mailroom will turn around and put an address, a delivery address on here, right? Like a street address, 21 Main Street, Portland, Maine, or wherever it happens to be. Mailroom then hands the document off to the mailbag stuffer. This is a company mailroom. They've got mail going to all these different organizations. So you're going to have mailbags going to West Coast traders. You're going to have mailbags going to Company A, Company B, whatnot. The mailbag stuffer makes a note on this outer envelope saying what mailbag is going in and sticks it in there. At that point, that entire mailbag gets tossed into the mail truck, right? The actual delivery vehicle. The delivery vehicle is what drives the mail to its destination. So in this case, the mail truck takes that mailbag destined for West Coast traders to West Coast traders. From there, the mailbag stuffer on the West Coast traders side pulls out the document and hands it to the mailroom. I mean, the mailbag stuffer doesn't care where in the organization this thing is going. All he or she cares about is that it arrived at the proper place, and it did. It goes to the West Coast traders' mailroom. There, the mail handlers look at it and go, oh, this is heading for Susie, the CEO. And then they turn around and hand it to their middle manager. Their middle manager, if this was sent with delivery confirmation, this is the person who tears off that little delivery sheet card and sends it back into the system to be sent back to the middle manager at Acme, right? Or if it didn't have delivery confirmation, he simply hands it to Susie's secretary. If the message was encrypted, if it was a big secret, this secretary would decrypt it, because being secretaries, they have the keys to be able to do that. And because it's in the right format, right company letterhead, right font, whatever, this secretary is able to pass the message up to Susie, meet for golf. Well, guess what happens when Susie sends her response back? Yeah, absolutely. The same thing repeats, only now it goes down her stack. She sends a response back to her secretary, to their middle manager, to their mailroom, to their mailbag stuffer, delivery truck, back this way, and then back up all the way up to Bob. And this happens for every bit of communication between the two companies. Well, I'm sure you figured out by now that wasn't just a bedtime story. That was a metaphor, if you will, an analogy for our network models. We have two of them, right? We have the OSI model and the TCP/IP model. Why did they do that to us? Did they just do it to make it hard on us? No. The OSI model stands for the Operational Systems Interconnect model. And this is what we call a descriptor model. It defines this technology, right? The TCP/IP model is the practical application of the OSI model. This is what we're actually using for our network communications. The OSI model has 7 layers. The TCP/IP model has 5 layers, 4 depending on who you ask, but for our purposes we'll call them 5. And for the most part, they're the same, right? The layers start at the bottom, so we always start here at the bottom for layer 1. And up here we count all the way up to layer 7. Up here we count all the way up to layer 5. And the layers are the same, except that they're named different things. The OSI model calls layer 1 physical. The TCP/IP model calls that same layer hardware. OSI, layer 2 is data link. Layer 2 on TCP/IP is network interface, network, internet. Both of them call layer 4 the transport layer. And what's going on here? Does TCP/IP not use the presentation and session layers? Not at all. It totally does. But what it does is it puts session, presentation, and application all into the application layer, right? It abstracts it. So these three things are all represented by here. Why a layered model? What's going on with this? The idea behind the layered model was to make our network communications future-proof, or at the very least, future-resistant. The layers are independent of each other, right? Layer 7 does not care what's going on at layer 6, or actually let's use our TCP/IP model. Layer 5 does not care what's going on at layer 4. Layer 4 does not care what's going on at layer 3, and so forth. Each layer only cares about what's happening at its own layer. As long as it has the proper interconnects to talk to the layer above it and below it, this is modular, right? I can rip a technology out of a layer, plug a new one in, and again, as long as it hooks up correctly, nobody else cares. This stuff isn't new. We'll talk in a minute here, but this was devised back in the late 1960s. Why are we still using it even now? Because it is future resistant. It is effectively future proofed, and we'll probably use this model for quite some time. So what was up with our little story we just told? Well, our story, Acme and the West Wind traders there, are analogous to our TCP/IP model. The secretary was the application layer. The middle manager was the transport layer. The mailroom, our internet layer. And our mailbag stuffer is our network interface layer. Really, our mail truck was the hardware layer at the very bottom, right? Again, in some models, the TCP/IP model is represented as 4 layers, others it's 5. Either are correct, although we'll consider them 5 for our purposes. What about the CEO, you ask? Where does this person fit in the model? They don't. The CEO is not part of the infrastructure. The CEO is not part of the TCP/IP model. We are the CEO. When you get on a computer and send any kind of network communication, whether it be something through Facebook, email, your web browsing, instant messaging, whatever, makes no difference. We're the CEO, right? And we send our messages into the stack. We send it into the application layer. So what's going on at the application layer? Well, protocols used by our applications live at the application layer. Notice I didn't say the applications live in the application layer. They don't. What is an application? Outlook Express, Chrome, whatever messaging application I'm using, whatever messaging program. All that stuff lives up here with us, right? Let's use email, for example. Microsoft Outlook. Email uses a protocol called Simple Mail Transport Protocol, SMTP. Well, what lives here in the application layer is SMTP. Here's examples of other ones, Telnet, FTP, File Transfer Protocol, and so forth. The program, the application, actually lives up here with us, outside of it. Also in the application layer, formatting, right? Different protocols, depending what I'm using, have different formats. Well, it's the application layer that applies that. Or the presentation part that lives within the application layer. Encryption also is handled here. Right? A lot of our network communication is encrypted. Ever do any online shopping? You better hope it's encrypted. Well, that's where it happens, right up here at the very top. Layer 4, the transport layer, reliable or unreliable communication. Do we want delivery confirmation for each and every transmission we do, or do we just want to hope for the best? Believe it or not, the vast majority of our network communications are reliable. which means we get delivery confirmation, right? I have two protocols, and we'll explore this more in depth in upcoming weeks. TCP or UDP, right? Transmission Control Protocol gives me delivery confirmation. UDP, Uniform Datagram Protocol, doesn't. Down here at the internet layer, this is the realm of networks, right? And we use network addressing, IP addressing, internet protocol addressing. You're kind of seeing where this model took its name from? TCP, the Reliable Transport Protocol, / IP, Internet Protocol from Layer 3. Now, different pieces of equipment live at different layers. Routers, those pieces of equipment that connect networks together, live at Layer 3. They are what we call Layer 3 devices. If you're talking about an IP address, that lives here at Layer 3, the Internet layer. When we get down into Layer 2, the network interface layer, now we're getting into the role of physical things, right? We're talking about the network interface card. At this point, I can put my hands on this stuff. A network interface card is a physical thing. Every network interface card, every NIC, has what's called a MAC address, right? It is literally an address burned into the chip of the NIC that uniquely identifies it on the entire planet, in theory. In reality, there are multiples, usually because of manufacturer defects. Cover more of that in upcoming weeks. But it's a physical address. IP addresses up here at Layer 3, they're not physical. They're logical, which means I can change them, right? I'm not stuck to any particular IP address. Everything else being equal, though, my MAC address is a permanent thing. A MAC address is like a tattoo, right? If I tattooed my name on my chest, Glenn, that's my MAC address. I could put a sticker over the top of it and said, no, my name's not Glenn, it's Bob. But that would be a logical address. My actual physical address is burned into me. Remember we were talking about network devices and switches, right? Those things that we use to plug computers into? They, by definition, are Layer 2 devices. They live here at Layer 2. They have no concept what's going on above them, right? All they know is Layer 2. And here is where protocols like Ethernet live, which we'll explore more later on. Right at the very bottom, at the hardware layer, there's our mail truck, right? Hardware, in this context, refers to the transmission medium, right? Cat5e cable, a piece of copper cable running across the room, or running across the building, or running across the city, whatever. It is the physical medium on which our data is transmitted over. This could be a piece of copper, it could be fiber optic, it could be point-to-point microwave relay, it could be satellite communication, it could be wireless, and my Layer 1 device becomes a radio transmitter, right? That's what our wireless devices do. That's all defined right there. So as we can see, separate things happen at the different layers. And in the upcoming weeks, we'll be going through and defining going into detail about what's going on in each layer. Critical. You need to know these two models, and you need to be able to know what the layers are. And by the end of the course, know what's going on at each particular layer. I have a couple of little memory joggers that help with this, right? Now feel free to use your own, invent your own, whatever. These are ones that I was taught many, many years ago, and they've stuck ever since. So I'm going to pass them on to you. For remembering my OSI model, right? Look at the first letter of each layer. You know the 7 layers. You have to know 7 on one and 5 on the other. For the OSI model, physical data link, network, transport, session, presentation, application. Please do not throw sausage pizza away. I hope not. I love sausage pizza. And I'm actually starting to get kind of hungry. So please don't throw it away. But it's a great way of being able to remember your 7 layers of your OSI model. Over here on the TCP/IP model, 5 layers, right? Application, transport, internet, network interface, hardware. All trains, indeed, need horns. Okay, not bad. We've just cracked the surface of where we're going to go with this. Again, this is the fundamental, the foundational knowledge of what the rest of our network infrastructure is based on. We're going to come back to this and back to this every day. And that concludes our lecture for week 2. Remember that we have assignments due. Feel free to be sure to check on Blackboard what we have going on. Any questions, please don't hesitate to contact me. And I will see you next week.